truth is that it's becoming a normal part of our cloud environment. And we can see that with these large AI systems that a lot of our teams are adopting, whether it's self-hosted. So if you've heard of things like Ollama or models that are deployed on Kubernetes. Some are taking the more managed route, so things like Amazon Bedrock and your OpenAI. And then there's the everyday AI use that you may be doing, where it's summarizing your emails for you or writing your LinkedIn posts for you. The second part is AI is not just responding. Now we have MCP servers, we have agents, and that allows it to start acting autonomously in your environment to run actions or to do any workflows. Think, for example, a finance agent that is in charge of vendor invoices. It can go in, it can read emails from a vendor, it can match it to the payments that were made, it can check the vendor logs, and then start a automation task for the finance team to go and approve it. And the third area where it's showing up is on the developer side. So developers are using AI heavily to complete a lot of their work and write code. So whether that is locally using things like IDE extensions in VS Code or other platforms, or remotely with GitHub apps. So you may have heard of Claude Code, GitHub Copilot, OpenAI Codex. All of these things are helping developers write code faster and ship things into production a lot faster than they previously did. So we see these three areas that AI is becoming a part of, and it's everywhere in the cloud now, and it's heavily integrated into all of these systems that already exist in our current cloud. So the first question is, well, if it's so heavily intertwined, where do we even start? There's two things first that we need to understand before we focus on how to address this. The first is the AI impact that it's had on the attack surface, and the second is the actual behavior of the attackers that it's changing. So if we take a look first at the changing behavior of our attackers, things like phishing, reconnaissance, exploit research, you've heard of them before, and they've always been part of the attacker's playbook. Nothing's really changed. The only thing is that attackers have access to AI systems that's going to let them do this much faster and at a much larger scale. Things like phishing, they can make it so much more tailored to the person or the organization, and it becomes so much more believable. Reconnaissance can be easily automated to go and gather large amounts of data and gather insights about it. And from the exploit research side, as we've all heard, AI is becoming pretty good at reading open source code and understanding what an application does. That also means that it's getting good at understanding where are the weak spots in an environment. And once you have a vulnerability, that time between the vulnerability to when it's exploited significantly decreases. And an interesting example we're actually seeing a change in as well is on the systems and on the actual machines where there's malware. So traditionally, a lot of attackers, they had to write very specific code if they wanted to have malware on a machine that was very specific to that machine and system. They had to understand the foundational layers like the operating system, the file system that's there, all the permissions needed. And then on top of that, they had to evade all the security controls as well. But we're seeing something new now where attackers just need to use a plain language prompt that tells the AI to go into the machine and start running actions. So find the sensitive files, find sensitive data, find specific docs, or generate malicious commands in the environment. So that's the first side of things. The second is the actual attack surface of your environment. For AI to be valuable, it has to be connected to things that are important in your environment, like the data in your environment, the identities in your environment, the tools and services that you have, so that you get the most value out of the AI. That also means that it's creating a lot of entry points for the attacker, and it's expanding that attack surface in your environment. Attackers can take advantage of what already exists. They can take advantage of the models and the prompts if they're not properly secured with proper guardrails to go in and run malicious actions in your environment. And at the same time, there's the AI-specific components to it, right? There's the malicious models that's going to affect the behavior. If there's a malicious prompt that can expose secrets or sensitive data, and even the MCP servers show the different tools and capabilities that are being used in the environment. And there's the highest impact version of this as well, which is the agent compromise. So if an attacker can compromise an agent on behalf of a user or workflow, and they can go in and run malicious actions in the environment that the organization trusts. And with the attack surface, we've all heard the term of vibe coding, and that's expanding the attack surface even more. Because we have people that are writing code and introducing more software into the environment that aren't normally part of the development lifecycle. People that sit out of the product and out of the engineering teams that now have the ability to easily be writing code and creating agents and having software in the environment. That means that they're also introducing more risk in the environment. There's also the developer side, so our experienced developers, of course, are also heavily using AI in their environments to help write their code, which means that they're also shipping much faster and building much faster so that they can continue to innovate. So both of these people that are vibe coding in the environment, a lot of basic security checks can start to get missed. Things like where's the authentication happening, where API keys and secrets are being stored in the environment, even something as simple as the database. Is it publicly readable for everyone on the internet? So security has this attack surface and these new areas that they need to be on top of and teams that they need to trust that are writing software. And if we're vibe coding, the attackers are also vibe coding, known as vibe hacking. And we saw an example of this last year in late 2025, where there was the NPM package, open source package, that was most of people use in their development. And attackers were able to add a malicious tool into it that actually told the malware to go into these developers' local environments, and it would prompt the local AI coding agents like your Gemini and your Copilot to find sensitive data on those developers' machines and environments. So we're seeing both sides of the equation, vibe hacking and the vibe coding. So the question you're asking, well, if it's changing the attack surface, it's changing the attacker's behavior, and it's everywhere in our environment, what do we do about it and how do we secure it? And the first answer really comes down to you need to have visibility first. But that's a lot easier said than done. The reason is that traditionally, visibility is broken down into 4 layers. So when we look at an AI application like shown in this diagram here, there's first the infrastructure layer, which you may be familiar with your normal Synapse tools that you have. You have the AI agent. You can see, is it publicly accessible? You can see the containers or any databases it's connected to, any permissions it has in the cloud environment. So that's the first component. The second is the actual model itself. So what is the model that's running? What are the tools that it's using? What is the data set that it was used to train it? And what are the guardrails set? And then any misconfigurations like prompt injection or malware related to the model or any of these components. And then there's the data side, right? This is the questions execs love, which is where's the data in our environment, where's the sensitive data, and what data do these AI agents have access to? And it's both sides for the data. There's the training data that's used for these models, and there's also the data that it has access to in runtime when you go and you ask it a question and it's gathering that information. And then finally, there's the application security side to it, because at the end of the day, these AI apps are still apps. They have things like the authentications, the APIs, the dependencies. There's code to it that is sitting on a repo. There could be vulnerabilities related to that code. So there's still the application component to it as well. And so with these 4 layers, traditionally they're very siloed. You have the cloud team looking from the Synapse view of things. You have your AppSec team looking only at the application side. Same for the model side and same for the data side. The problem is they're only seeing one small part of the overall picture that we have in front of us here. And the problem with having all these silos is that we're creating gaps and blind spots in the environment. And who loves blind spots more than the attackers wanting to come into our environment? So you need a way to actually have visibility of all of these layers from end to end. At Wiz, we believe that to unite all these signals together in a graph, to be able to see things from when it first became in existence in code, all the way to all the layers that we have in cloud and all these layers that we talked about to the runtime. So from code to cloud to runtime, all of it unified together in a graph to give you all the information that you need. And with this graph, then all the teams here, so your team for cloud that's normally looking at the Synapse tool, or your AppSec team, they all have that same view. They have a shared understanding of what is in the environment, how everything is connected, and why something is important, so that when there is a risk in our environment, let's say here there's a vulnerability on a container, or there's a misconfiguration on our AI model and the guardrail that's set for it, everyone has that same context and evidence they can use because we're all looking at a shared story and a shared understanding of what exists in the environment. And that's easier said than done, connecting these AI security dots, especially when you have these traditional siloed tools. It's difficult because all of these layers, they have their own tools and they have their own behaviors and capabilities. Like your model, it's going to depend on if it's a SaaS, a PaaS, if it's self-hosted. Your agents, they can be running in browsers, they can be running in the IDEs, they can be extensions. Same from your data, it's flowing through different pipelines, different systems and data stores, or if it's in runtime, and even your identity and permissions, whether it's a cloud role, whether it's something related to a SaaS, whether it's a service account. All of these run very differently, and it's very hard to piece these pieces together if you're looking at them in these silos. At Wiz, what we like to say is that there's good news. We have what is called a home field advantage. As defenders, we know what is in our environment. We have all the context of what is our environment supposed to look like, what are the applications that we have running, what is considered normal behavior, what is critical to our environment, and where does that sensitive data exist. These attackers, they are on the outside, and they only have an outside-in view with generic AI models. So we have that home field advantage of all the context of what exists in our environment. And when we have that context, we can leverage it, and if we add our own AI on top of it, to be able to reason over it and give us insights so that we can react as fast as these attackers are coming in, or even faster than the attackers before they come in. So we have these 3 components. We have the graph, which is giving us the unified visibility for all the teams that are related to security, or even our developers. We have the context around it and how everything is connected. And then we have the last component, which is adding our own AI on top of it, so that when there is a risk in their environment, we're able to understand the risk and act on a risk without having to try to piece together all the different components from all the different tools that we have. At Wiz, that is what we believe is the foundation for starting with AI security. So if you have any more questions, happy to answer them now. We have 5 more minutes, and I'm also at the Wiz booth all day today. Thank you. Yes.
I'm just how do you think maybe AI threat modeling? How do you think AI threat modeling could help in sort of detecting threats and sort of helping throughout this SDLC process or I want to say sort of development phases in predicting what risks could exist and how we can take sort of like this, I want to say more defensive approaches in sort of like after we sort of understand what threats could exist at different stages, how can we take more preventative, I want to say actually approaches to prevent them?
Right. So with AI, we want to be proactive in terms of looking at risks into our environment. And this graph is really the first step in having the visibility, because if we can see how everything is connected together, then with AI on top of it, we have an understanding of if an attacker were to come in, what are the different attack paths that they would want to follow? Because when they come into their environment, they want to do max damage. They want to hit as many things as they can in our environment, gather as much data. So being able to look at it from their perspective and seeing if they were to come in, here are all the places that they can follow, all the paths they can take. And so being ahead of that and being able to address that using AI to model these kind of behaviors.
Can I add to that?
Sure.
So when you're developing, you can actually set up a markdown document that will, as they're coding, you can have it say, I want all of the OWASP top 10 to be addressed. Sure. You can have it set it up and just write, like I'm saying now, ensure that all code developed meets OWASP AI top 10, meets X framework or Y framework, builds in privacy by design. You can put all of that in so that the code that it actually comes out at the other end, you'd want to test it, of course, but you can have it set up and create the context so that it's actually built with security in. So we often talk about shifting left, right? And sorry, I don't mean to take over, but we often talk about shifting left, but this is actually the opportunity for security folks to shift left and do it and deliver it. So.
Yeah. Yeah, absolutely. And it's interesting to think because a lot of times, if we think about the developer teams and the security teams, there's always a bit of conflict, right? Because developers feel like security is slowing them down. But if we can have like the idea of shifting left, right, already having in the process, the developers are able to see where the risks are before they're even shipping out that code. And having context and evidence to tell them this is why this is a risk and this is why it's important in your environment before it even reaches production. Yeah.
You talked about the attackers having the generic AI models, right? Could you talk about the AI-powered Wiz? Are there any specific AI models used within Wiz to kind of protect that?
Yeah, so in Wiz, we like to say that we just use the best of breed in terms of AI. We don't like to stick to one specific AI model because they're always coming out with new models and new versions. So we actually like to use the best version that's out there regardless of what platform or company it's coming from. Yeah.
Would Wiz be able to identify the processing data for each of these AI workloads or these tools app? Like what's the type of data that these tools are using and flag those assets?
Yes, so Wiz is able to connect to your environment agentlessly. In 15 minutes, we do a setup, and it does a read-only of your whole environment, so it can see everything in your environment regardless of what cloud service provider you're using or what SaaS platform exists there, and it can see all the resources that you have in your environment, the kind of data that is running. We can see all the way back into the code that led to the production of what's in your cloud environment and also from the runtime side. Awesome. Okay. If there's any more questions, I'll be at the Wiz booth today. Thank you so much, everyone.